On this absolutely fantastic day. Let's get right to it, shall we? So, the first thing I'm going to have you do is, believe it or not, get out your math notebook. So, I'm going to ask you to pause this video and go get your math notebook. I'll wait. Okay, you're back. So open up your math notebook to your next fresh, clean, blank page. We're going to take some notes today. It's not going to be a lot of notes. It's just going to be something to kind of bridge the gap from where we were in multiplication and where we are going, because we're going to be starting a new method of multiplication today. So let's start with where we were. Let's start by going back to the past, okay? And we're going to do a quick little sketch of area model, which is what we were doing previously, okay? So I want you to write area model, A-R-E-A, that spells area, and M-O-D-E-L, and again, I say this a million times, and I'll say it a million more. Pause the video as many times as you need to if I am going too fast, all right? Don't ever be afraid to pause the video over and over and over again. So we're going to start off with multiplication problem 2 times 75. And as is in the past, the second number is always a 2-digit number. We will be getting into 3-digit numbers pretty darn soon, actually. But we're still going to stick to the 1-digit by 2-digit, okay? So we start off by drawing a rectangle, and then usually a smaller rectangle or a square right next to it. Okay, and there's a reason why. I don't think I've ever really talked about why the fact that this one is always smaller than this one. It's because when we take the second number and we break it into we separate it into like expanded form, you know, into the value of each digit. This value is going to be larger than this value always, because this value right here is the tens and this value is the ones. That's why this rectangle is always longer than that one. Okay, so as I just gave away, we need a length and another length, right? Because when you figure out area, it's length times width, right? So the value of this 7 is, that's right, it's 70. So we're going to put a 70 right there. And the value of the 5 in 75, of course, is just 5, and that goes right there. So that's length and another length. And the width is whatever the 1-digit number is. In this case, it's a 2. We're going to put it there. So as we remember before, length times width gives us the amount of space on the inside, which we call area. Now, you may not, off the top of your head, know what 2 times 70 is, but I'll bet you know what 2 times 7 is, because it's the same as 7 plus 7. That's right, it's 14. But 2 times 70 isn't 14. That doesn't make any sense, you know? So, okay, there's a 0 right here. So if there's a 0 there, we're going to place a 0 there, okay? 2 times 70 is the same as 70 plus 70, which is 140. That's area number 1. Area number 2 is the length of 5, the width of 2, because remember, whatever is over there is also over here. And so 5 times 2 is 10. These are what we call partial products, right? So we need to add these products together. Let's rewrite the multiplication problem instead of horizontally, vertically, which is what we're going to see way more often now. 75 times 2, right? Partial product number 1 is 140. And notice how I'm lining them up like toy soldiers, right? All the ones, yeah, my 2's a little off, but all my 1's in the same column, all my 10s in the same column. And then, of course, oh my goodness, you want to talk about easy. Give me a break. I mean, seriously, give me a break. So 150 is our final product. Now, that is the way that we have been doing it up to this point. Today, we are going to explore a new way. All right, and it's called the standard algorithm, or I'll be calling it standard. Standard means normal, the normal way that we typically do things. It's called standard. So I'd like you to go a little bit further down on your page, skip a few lines, and we're going to write the word standard. S-T-A-N-D-A-R-D. RD. And we're just going to write the word standard. I mean, it is called standard algorithm, but I'm not going to go there. Just going to have you write the word standard because this is this. So here's what we're going to do. We're going to write the same exact problem we just did, except we're not going to be writing it like horizontal like that. We're just going to be writing it the vertical, typical way that we normally see, which is 75 times 2. Now, we are not drawing any rectangles. We are not drawing any squares. We're not doing that, okay? So what we're going to do is we're going to multiply like this. We're going to still have two partial products though, okay? We're going to start off, step one is you take this bottom number 2 and you multiply it by the number in the ones place, which is 2 times 5. And in fact, over here in the parentheses, we're going to write 2 times 5. Okay, so 2 times 5 is step 1. And the answer to that, of course, is 10. Now, the next step, since we're multiplying by the value of each digit, is not going to be 2 times 7. It's going to be, just like with the area model, 2 times 70. Okay? And as we know from the previous example, it's 140. Now, you might notice when you compare these that the partial products are in the opposite order. The 140 is on top and the 10 it doesn't really, with addition, it doesn't really matter where they are, right? So this is the way for standard algorithm. It looks a little lopsided, right? We're usually used to seeing the larger number on top. It doesn't really matter. And this is the way that we do it. We always go up and then over, up and then over. 2 times 5, 2 times 70, 2 times 5, 2 times 70. We always go in that order. And yes, we add the partial products just like before. And of course, we get the same exact answer as we did up here, 150 and 150. Okay, so this is the way we are going to be exploring today. Okay, this is, and I'm going to put a little smiley face on it because this is the way that most often we're going to be doing it. This is actually, if I want to be honest, it's technically not standard algorithm, really. It's kind of called expanded algorithm. So maybe I should change that. Let's change that. This is actually called expanded algorithm. Standard algorithm, so we're gonna place a respectful scribble over standard. It's not really this. Standard is something that's going to be coming soon. It's more of a shortcut method where you completely eliminate all partial products. So you know what? Now that I think about it, let's not call this standard for today. Let's call this expanded form. Okay, it's called expanded form because just like with up here, you are expanding the 75 into a 70-5. You're also expanding it into a 75. So standard, you're going to come later. Naughty standard trying to break into today's lesson. That's not what we're calling it yet. You're going to come in the future. So let's call it expanded for today, shall we? So I would like you to do the following. You can keep this open, please. Keep this open. This is a great idea to keep this with you. And what I'm going to do is I'm actually going to ask you to go and get your green math book. And I want you to tear out page 43. I will pause the video while you do this. And if you want to get yourself a multiplication chart, you are certainly welcome to do that as well. Okay, so pause the video and come on back. Hey, welcome back, everybody. So page 43 from your green book has some examples in it, right? And this looks just like our notes over here, right, for expanded form. So check this out, gang. This over here, I'm going to be honest with you, all right? We're not really going to use these boxes. I'm not going to use that. I just want to dive right into expanded form right here. So let's do a couple together, and then I'll have you try a couple on your own. So this first one is 2 times 43 or 43 times 2, doesn't really matter. So over here to the side, I want you to write 43 times 2. Okay, now remember, we're going to multiply by the value of each digit. So the first thing we're going to do is pretend like that 4 isn't even there and do 2 times 3. Mr. Brown, do I have to write the parentheses to the side? Yes, you do. At this point, it's very important that we know exactly what step we're doing when. So I want you to write 2 times 3. Again, pause the video as many times as you wish. That, of course, is 6. Okay, because 2 times 3 is the same as 3 plus 3. That's partial product number 1. Partial product number 2 is actually, please remember that the value of this 4 is not really a 4, it's actually a 40. Mr. Brown, why'd you put that little 0 right there? Sometimes I do this when I am multiplying with expanded form to remind myself that this is not a 4, it's actually a 40. So you are welcome to do that as well. I know I didn't do that in the notes. I mean, heck, if you want to go back to your notes and you want to say, hey, put a little, put a little 0 right here, go ahead, do it. To remind us that was a 70, go ahead, go back and do it. Yeah, the second partial product will be 2 times 40, not 2 times 4, right? Remember, we go up, then over, up, then over, up to the left, up to the left, up to the left, doodly-doop, and that's a 40. Okay, so 2 times 40 is 80. Wow, that is insultingly easy. If that was salsa, it would be mild salsa, because man, oh man, come on. Really? That easy? Really? Come on. So, okay, that's example number 1, doing this together. Let's do another example together. Mr. Brown, I want to try one on my own. Be patient. It's coming. It's coming. So the next example, and again, we're going to go, I don't want that. I don't want that. Just a gentle X, right? Not like a maniac. Gentle X. Let's be gentle today, boys and girls. Let's be gentle. Let's write 43 times 3. Mr. Brown, isn't that what we just did? No, we just did 43 times 2. Pretty darn similar, though. So let me remind you, or let me ask you a question. What 2 numbers do we multiply first? You're right. It is 3 times 3. 3 times 3 is the same as 3 plus 3 plus 3. Yep, you're right, it's 9. That's partial product number 1. Okay. Remember, the value of this 4 is a 40. It's not a 4, it's a 40. So our second partial product is 3 times not 4, but 40. I happen to know, even if you don't know what 3 times 4 is, check this out, gang. If you don't know what 3 times 4 is, but you know what 3 times 3 is, which is 9, add another 3 to this answer. And that tells you what 3 times 4 is. So, every time you're just going up by 3 every single time. Hey, Mr. Brown, that's 12. Okay, so is 3 times 40 12? No, it is not. 3 times 40 is 120. And yes, you are going to line them up like toy soldiers. Can we please get an addition problem that's not ridiculously easy? Please? People that make the green book? Seriously, you're killing me. You're killing me here. Give me a break. I mean, come on. This is an insult to our intelligence. So, yeah, that's that. So, again, make sure you have everything that I have, because this paper is going to be collected and I'm going to look at it. So make sure you've got this and you've got this 100% exactly like I did it, and then flip the paper over. I'll tell you right now, these are the 2 examples you're going to be doing on your own. 2, A, and B. I will do this one with you as well, and I will do the very last one with you. So put a little smiley face or a star or whatever you wish next to these 2, 2A and 2B. These are the 2 that I'm going to leave blank, and you are going to try on your own. And I truly believe that you can do this. So 4 times 43, let's get crack-a-lackin'. Okay, 43 times 3, we're going to write this like this. Oh, you're getting the hang of this. I know you are. Because which one did we just do? Oh, wait. Hello. It's 43. I was like, wait, isn't it what I just put? It's 4. You see, listen, look at this. This is what happens when Mr. Brown doesn't have enough coffee. And guess how much coffee I've had? None. Can't you tell? Can't you tell? These mistakes I've made? Look at this, right? Come on. I accidentally called it standard when it was expanded. I put a 3 and a 4. I need some serious coffee today. I think you can all agree with me on that one. You can all agree with me. I need some stinking coffee, man. So first of all, we are starting our first partial product will be 4. We're going to pretend like that 4 is not even there. 4 times 3. 4, and yes, we are. Yes. And when you do these examples on your own, you are going to write those parentheses just like we have been doing. It is mandatory, it is not optional. 4 times 3 is 12, like we just said with the last example. And now remember, this 4 is not a 4, it's a 40. Again, this is deja vu all over again, Mr. Brown. All right, 4 times 40, partial product number 2. Well, let's see. I know that 4 times 3 is 12. And if I add another 4 to that, it will be 16. This is another way you can figure out multiplication facts you don't know. If you know the one right below it, then you could just add another number to it and you'll be fine. So that's 16, but it's not 16, it's 160 because there's that 0. Hey, we finally have something. It's still easy though. You know, it's still easy, Mr. Brown. Well, at least we have something to add. I mean, for heaven's sakes, right? We got something here. So 172 is this one. Again, you do just like this. Okay, do I have to put the little 0? No, but I do it that way. You don't have to. All right, last but certainly not least, and then I will let you move on with your lives. This one right down here is 4 times 84, but of course we're going to write it 84 times 4. Okay, please make sure you write that down. Maybe someday this little mystery dot will go away. Maybe I'll figure out what to see. This little thing drives me crazy sometimes. So the first one is 4 times 4, right? Because remember, we go up, then to the left, up, then to the left, up, then to the left. Okay. And yes, you're going to do the parentheses. Mr. Brown, I don't want to. Well, you have to. You got to show what you know, man. You got to show what you know. So the first is 4 times 4, which is didn't we just do that up here? Right? 4 times 4 is a 16 with a 0 after. I mean, come on. We just did that one. It's 16. And then next, that's not an 8. It's an 80. So it's 4 times 80. Now, Mr. Brown, I don't remember. Well, remember, I did say that you could grab a multiplication chart, right? And you could use that. I said you are allowed to do that, right? 8 times 4 flowers are what they grew. And on the pot, it said 32. But it's 32 with a 0 after it. Right, 320. Yes, this is not the most challenging addition in the world. You know, what could I tell you? You know, really. So our final product, these are partial products, is 336. Boys and girls, I believe in you. And I always will. Okay? Take a look at what you already have on your paper and use that as a guide. And heck no. We're not doing that, and we're not doing that, and we're not doing that, and we're not doing that. Gentle X's. Okay, we're not doing any of those. Okay, we're just not but what is it, Mr. Brown? Don't worry about it. We're just not doing it. I really just want to dive into the actual procedure today. Okay, my friends? So again, I believe in you. After you do these 2 examples, you are going to hand it into the adult in the room. I'm going to check it out tomorrow. We're going to review this tomorrow, and then we're going to have a fantastic day. All right? Nice job, everyone. Hope you have an absolutely wonderful rest of your day, and I will see you later. Bye-bye.